Story time. The mechanism is predicated on this floating valve going up and down, up and down. I have some experience launching and selling companies, as you can see. My good friend and I, Justin, had an idea to improve water dispensers for dogs. The typical automatic self-water dispenser looks like this, with a gallon upside down using gravity to get the water in the bowl. But there's a lot of problems with this. Problem number one, the water in the bowl is the same as the water in the tank. Therefore, when the dog's saliva gets in the bowl, it also gets in the tank, and it makes it a very filthy and arduous process to clean. The other problem is time. If you have large dogs and you have to refill this water tank every day. So we did our market research in the first 3-4 pages of Google and came across other devices that were pretty much the same mechanism, the upside down tank that used gravity. But none of them addressed the two main problems that we listed before. We did run across an electronic water dispenser, which is kind of what we had in mind, but we wanted to develop something that was purely mechanical because we didn't want to risk the water bowl failing due to the battery failing. So I went ahead and created a proof of concept prototype that was inspired after the toilet bowl mechanism. As you can see, this is using springs, so depending on the amount of water, it'll dictate the amount of weight that this separate bowl has, and the bowl water is disconnected from the tank water. So that was one of the requirements that we had. There'll be a continuous water flow coming in through the back, kind of like the toilet. And once the dogs consume the water, this would rise because the spring force would push it upwards, and that face will come in contact with this knob. The knob will turn, and there'll be a chain attached to the knob, the same as the toilet mechanism, and the water will come in the bowl. So we came up with this proof concept prototype. We're about 6 hours in the project so far. I was starting to become skeptical because how could it be that no one had designed this before? The market was huge. Homeowners, dogs, you know how much they love their dogs. So we decided to do a second round of research, and my astute colleague Brandon ended up finding the product that does everything that we wanted to do for only $40. So that's the end of the story. We didn't start the startup, and that's the end. Just kidding. Now that we found this product, we looked at it and we said, hey, why not buy it, tear it apart, study how it works, and reverse engineer in CAD. So that's the second part of the video that I'm going to show you. Here we have the CAD model. First, I'm going to show you part by part how it's all assembled together, and then we're going to look at the mechanism. So here we have the main body, the bowl, injection molded, of course. Then we have the floating valve, which is actually the first thing that I began modeling, and is the most precise out of all the reverse engineering that I've done, because I wanted to capture the geometry as closely as possible. We have a little pin that goes through here. The pin goes through the housing. Let's make this housing transparent so you can see what's going on inside. And then we have, of course, the bowl. And lastly, we have the hose tip, which is where the water enters the bowl. The mechanism is predicated on this floating valve going up and down, up and down, up and down. So what's going to make this floating valve go up and down, you may ask? Let me show you. So let's take a side view. And the floating valve goes up and down. The water is entering through the back, here through the hose tip, and it trickles down. It goes all along, and it enters the bowl. The water begins to raise. It begins to raise the water level, and this water level has a buoyancy force that's applied on this face that I'm highlighting right now, and the buoyancy force is going to move up the floating valve. Now you may see that some faces are overlapping when they're not supposed to, but this CAD model is simply for educational purposes, so it's not perfect. So as the water valve begins to rise, let's focus on what's going on in the back. So water is entering right now through the hose tip, but as the floating valve begins to rise due to the water level, it stops the water entry once the water level gets to a certain height. And that's what prevents water from constantly entering the bowl. So the dog comes over to the bowl, drinks some water, the water level goes down, it automatically prompts for water entry through the back. The water level begins to rise, and the water entry is blocked off. Simple and ingenious. The most complicated part of this model is creating the surface that connects the bowl and the back. As I'm going to show you, there's a curved surface right here. I'm going to move the feature tree down. So this surface that I'm selecting right now in baby blue, that's the most complex part. And how I did this is a principle on how to use surfacing for cutting, and I'm going to show you. So you want to cut this red body using the green faces here and here, but you can't because when you do the intersect feature, it fails due to various reasons. So this is a process that you need to repeat over and over again that I'm going to teach you, that you should definitely incorporate to your skill set if you're a mechanical designer. This is how it works. You select the face that you want to convert into a surface. You go to surfaces, you want to copy the surface, so you simply, instead of 0.1, you give it a 0. That copies the surface. Then you find the surface wherever it may be. You got to go up the feature tree up or down. Let's isolate that surface, and you want to extend that surface. At least this part is what we care about. Play around with the same surface or planar. I like linear for this. Well, actually linear or yeah, I like same surface for this one. So we extended it beyond what we needed, just in case so it doesn't error out. Now we have this surface that we can use to cut the red body. So you repeat that process over and over again for all the parts that you're interested in, all the surfaces that you need. I already done that for you, so they're all in yellow. We have a red body, and now we do the intersect feature. Once you do the intersect feature, you finish with this, which is the part that you wanted. And let's hide all of our surfaces that we don't need anymore. And with this body, you can mirror it to the other side. You combine all the bodies. But we have some hard edges, some sharp corners. Of course, we're going to put some fillets. And that is how we end up with that curvature that connects the bowl and the back. In conclusion, although I am comparing 6 hours versus hundreds of hours, I can see my shortcomings when I do the comparisons as to how these engineers solve the same problem that I was trying to solve. They made it easier to assemble, easier to manufacture, there are less parts, less hardware. The hardware that they use in this little hose head, it's a lot cheaper hardware than the hardware that I utilized in these rails and maybe these custom knob that I had to make and these springs. If you look at their part, it's only 1, 2, 3 injection molded parts, a toothpick, super cheap, and this head. Lastly, if we keep on doing these exercises together of studying the marketplace and the products out there to see what engineers and engineering firms have done to improve their products, to make them competitive in the marketplace, we look at the parts they used, how they solved the problems, the features they utilized, why they use those features. And if we can keep on learning, this is arguably based on speaking with dozens of engineers, senior engineers, this is arguably the quickest way to level up your skill set as a mechanical design engineer. So I'm very excited, as you can tell from my voice. I'm a constant learner, and hopefully you are too. If you are enjoying these videos, if you like my narration, if you like the way that I explain things, the products that I select, the little tips that I give you, give it a thumbs up, leave in the comments and say, hey, I'm enjoying Rafael's videos, we want more. And if you don't like them, leave a comment below, give me some feedback. Feel free to reach out to me personally on LinkedIn or Instagram. I'm looking for ways that I can improve the videos, and if you have any ideas of the products that I can choose on the marketplace and we can tear apart and study together, send me a message and we can study those. Until next time. This video belongs to a playlist called the Mental Mechanism Library, in which we're going to study products all around us, figure out how they work internally, and save their mechanisms in our Mental Mechanism Library. This is going to make you a better mechanical design engineer.